All right, so other than the hamvention, a little bit of talk of sporadic E, some of Dr. West's our directed studies of the eclipse data. And is there anything else that anybody would like to add to the agenda? I see Gwen's got with us today. If maybe sometimes you have a few things to add as well. Otherwise, that's just listen in is fine too. So anything else for the agenda?
I could say that a number of us are going to the CEDAR conference in a couple of weeks. So not next week or the week after, but the week after that. So June 9th, we'll be heading to the CEDAR conference. And we're going to be going around trying to show some results of the eclipses. And we'd love to show some results about the big geomagnetic storm we had as well. So if people are interested in getting some of those results together, we could potentially show them at the CEDAR conference. I will be away next week. I'm going to be at the NASA Living with a Star meeting. I think Mary Lou will be there with me. And so I won't be on next week. The week after that will be right before CEDAR. I am planning on being here for that telecon.
I know Mary Lou is out next week, and I'm going to be out next week as well. So David had a good suggestion about someone leading a discussion on sporadic E. There's a nice little thread going on the HamSCI Google reflector, so I'll put that question out there and see if we can get somebody to volunteer. It's a pretty good idea.
A quick question came out of the meeting this morning. Do you remember what date the that nice TID data came from?
Wayne Griffiths has it, and he's on, and he can talk all about it.
17th of May.
Okay.
Norwegian Independence Day.
We're going to take a look at our AM data and see if that shows up.
All right, well, let's get into the first agenda topic. Is Nathaniel, is there anything you want to say about the hamvention? I thought the whole thing went pretty well. We had a lot of contact. A lot of people came to our booth. We're either familiar with HamSCI or saw pictures of the grape and were interested, and hopefully they'll follow up and join in some of our activities. Is there anything you want to say, Nathaniel?
I'm just extremely happy with how everything at the hamvention went. It was a whirlwind experience for myself, and I'm sure many other people there. We had a lot of really fun conversations at the booth. Thank you very much to Gary for getting the booth all up and running. We had some very good booth talks. We also had a number of forum presentations. I got to speak in the antenna forum, and then we also had Gary and Rachel Bodeker and Jesse Alexander and Rob Robinette all speak in the HamSCI forum. And those forums are available on YouTube. We can get those links out to you. And I wanted to show one slide from my talk that I gave in the antenna forum, and that's this one. This is a slide I made up, which has all of the personal space weather station network stations, at least over the United States. And you can see that we have a total of 4 ground magnetometers set up, 97 Grape 1s, 24 Grape 2s, 18 Whisper Demon, 1 VLF receiver, and 9 Whisper Sons. So I think that is a pretty good tally for where we are so far. So very nice job, everybody.
So what states do you need people in?
These states over here, that one over there.
So things like North Dakota and places like that, right?
Yes, that'd be wonderful. We need to start getting up into Canada more, and I don't have many Mexican ham friends, but I should start making some because we could use people down in Mexico, more in down here in the Caribbean. So we definitely could do a lot to kind of expand beyond the continental United States.
I bet you could get Angel to host one in Puerto Rico.
I bet we could, and I even saw Angel at the hamvention. So I will. There's another version of this map that actually has a few stars proposing stations down in Puerto Rico.
Nathaniel,
I'll try to reach out to
you,
a few people in the Caribbean, Nathaniel, and see if we can get some over there.
That would be really good.
Is there anybody in Hawaii besides Rob?
Not at the moment.
Okay.
What were you going to say, Gary?
Yeah, I was wondering if I could get a copy of this presentation because, post Eclipse, we want to get together our standard presentation again like we did pre-Eclipse.
Yes,
And
I
I
can.
bet 95% of the material is right here, I think.
I can give you a. I can
I
put.
sent you a link in the chat. That's where all our presentations went from last week.
Okay,
If you want to put it up there, I can pull it back down from there later.
great. I can do that. Link in the chat. Chat. I don't think I got that link, Gary.
Hmm.
I don't have anything in chat.
Well, I just sent it to Nathaniel. Oh, it said direct message, huh?
Oh,
Okay,
there.
maybe I didn't hit enter. Sorry.
Okay.
User error.
This is actually on my OneDrive. So yeah, I can upload it there.
Okay, that would help. And Bill Lyles want a copy of that map too, so I can take care of that for Bill then, with that same map.
Thank you.
All right, any other comments on Dayton? I didn't get around to the vendor booth to see what was new. I know Bill Engelke was excited. He bought himself a Flex, what was it 8600? So
Oh, wow.
that'll be coming to him someday, replacing his older unit, so that's good for him. But I didn't go out into the flea market or do any of that kind of stuff. I was happy in the booth. So,
Yeah, and it
okay.
was-
Anything else on Dayton? We'll wrap that one up then.
Did
So
you
the
learn
one
any?
thing I did mention this to Nathaniel, I had nobody come to my booth talk. And I realized we do not have a list of those, I think, at the HamSCI booth. And at the Youth on the Air booth, it's back where people wouldn't see it. So I think a little more upfront advertising would be helpful.
Yeah, it's good feedback.
Yep.
Yeah, we printed, I think, 4 of those big schedules, and I remember taking them down after the Ham Fest, and we'll have to think about our placement next year then. Yeah, it was funny. I was giving George Kavanaugh's talk about 10 megahertz MUF and the dropouts in the Grape 1. And I walked to the booth talk area and there was one person sitting there. And who was it? Carl Lutzelschwab, K9LA. So here I'm going to give a talk about propagation to the one ham who probably knows about as much propagation as anybody. So we had a good laugh over that, but he still enjoyed seeing the slides and seeing George's work. So we had fun with that anyhow. So great. Okay. Kuldeep, you had asked about sporadic E a couple weeks ago. I don't know if you've seen the HamSCI Google reflector today, but there's been a few conversations back and forth about some information that's on the HamSCI website. Have you had a chance to see that yet?
I went to HamSCI website, but I have not gone into that Google, what you said,
I
The
noticed
Google
that-
group, yes.
Google
I
group.
noticed that Joe said he couldn't be on he apologized for not being able to be on the meeting today. Maybe he would be willing to lead a meeting next week.
That'll be 5:30 next week. Okay, we can ask, certainly ask. Okay, is there anything else, Kuldeep, you wanted to bring up on that topic for the moment? Otherwise, I think David's got a good idea. We'll try and arrange a speaker maybe on that subject next week.
Yeah, that will be great.
Okay, very good.
I just wanted to, not from my side. When Nathaniel showed personal space weather stations, there was something called Whisper Sound. Is it like digisondes? The ionosondes which we have in the ionosphere?
Not
Whisper
exactly.
Sound. Okay.
So the Whisper Sond is see, I think I have a slide on that. Get this back up and running. Wait. Let's see here. Yeah, right here. Just share my screen again. Oh, that's okay. Yeah, so this is a whisper sound. It is a 8-band transmitter, and it transmits whisper packets. So whisper is a particular type of amateur radio transmission that's used for testing weak signal propagation links. So it is not like a digisound in that it's not sweeping the entire HF band, but it is an active transmitter of sorts.
A transmitter with the 8 frequency bands.
Yes.
Yes, and
And
of note, it is,
Simultaneously.
and it is GPS discipline, so we can get Doppler off it.
Okay.
So
Okay.
what do you learn from this sort of thing?
Wynn, would you like to say anything about that?
Yes. So you have Doppler from it, either using Whisper or FST4W. So it's an average measurement over a 2-minute interval. That Doppler is logged by Rob Robinette's Whisper Daemon data recording system with a resolution of 0.1 hertz. Well, gosh, thank you, Nathaniel. You're faster than I am. So this is a whisper sonde in action during the last year's annular eclipse from W07I in Nevada near down to ND7M in Nevada, 545-kilometer path, where 80 meters in the brown was open all night. So you see the Doppler shift rise and then fall again during the morning descent of the refracting layer. And you see that 7 megahertz on that path length doesn't open until partway through that descent. But then you catch it on 7 with, of course, almost double the Doppler. And then even later, 10 megahertz in cyan opens, but it's still catching the descent. And then what you see is that 80 meters goes to 0 Doppler. So what's happening there, in contrast to the other 2 bands that are still showing variations, is that refraction now at 80 meters is from the E layer. So we don't see the Doppler. And this is around here. Well, you've got the maximum eclipse time. So this variation here is specific to the eclipse day, and we have other slides that then compare it to the 15th. So given the limitation that is averaged over 2 minutes, it's 0.1 hertz resolution. It does a fine job on multi-bands simultaneously. And of course, you can replicate these to your heart's content. A bit more easier than time standard signal stations.
So it looks like the maximum Doppler shift was 1 or half or 1 hertz.
Correct. But
Maybe
then when
half would be more likely, except for a few points. It's half a hertz, right?
half a hertz on 3.5 megahertz, about 1.2 on 7 megahertz. Yeah, and so those do collapse nicely when you convert those Doppler shifts to path velocity.
Do they come out the same then?
Absolutely. I can show.
6 twice 6 gets you 12, right?
Well,
Yeah.
it's within the 0.1 hertz resolution. And sorry if I'll open up. So I probably have to do that. How I get myself a Word document. I've just written this up for the RSGB Radcom magazine to submit it. So it's there we are. Have the path path velocity graph. So if oh, have I lost you?
You're still here.
Hello?
Yeah,
You
hello.
are
They're
there.
still there. Oh, sorry. I've just lost my own screen. Right. So, there we are. Share. Yeah. Let me increase that. So this is too many windows open. There we are. So this is the path velocity graph that goes with that Doppler graph, Mary Lou and or you all. So there we have sunrise. So you can see the 3.5 megahertz, 7 in the orange, and then later joined by 10 megahertz cyan. You know, within the resolution, they do fall on top of each other. And then, of course, you know, the E scattering, E refraction stands out at 3.5 megahertz. And then when you convert that into height and take point Arguello Ionosond for a reference height for your constant of integration, and then you go back in time and forward in time, then you know we can go all the way back here with 80 meters in height of reflection, and we go back up with the orange dots on 7 megahertz and the cyan, we can go back there, and then we go through the day here. So you know, I can observe this data. What I can't do is interpret why the apparent height of reflection followed the peak height in the morning, but then more closely followed the minimum virtual height in the afternoon local time. And then the eclipse, the normal day is in green, and the dots are 7 and 4 and 10 megahertz from the whisper sond.
Okay.
And then in magenta is the grape, so WWV to the St. George, Utah grape at 10 megahertz, and maximum obscuration was 7 minutes later. So you know, I think we have sort of an indication here that the two separate systems, Whisper Demon, Whisper Sond, FST4W, and an SDR receiver, and the WWV to a grape are giving very similar results during that nice perturbation.
What was with 7 minutes? Say again about that.
Now, the 7 minutes was the difference in the time of maximum obscuration between the midpoints of the two paths. The Whisper Sond path was entirely within Nevada, and then the WWV to Grape in southern Utah path was, of course, to the east by some 830 kilometer difference between their midpoints.
That's cool.
So it's a useful instrument.
And this involved what, 4 people or 3 people and a WWV, or?
In that particular case, yes. Yeah. So
Three
Robin
and 1.
3 plus WWV. Yes.
Power of citizen science.
So then the
What?
Whisper Sond comes from Turn Island Systems, which is really a name for Paul Elliott, WB6CXC. So it's Paul's invention, the Whisper Sond. And Paul is an incredibly talented engineer, and he has both designed that Whisper Sond and commissioned its entire build of the electronics in China to his design.
If you buy one of those, how costly is it?
Nathaniel may know better than I the sort of recent price.
You're looking between $1,000 to $1,500 for everything.
Yeah, it really is a beautifully made piece of equipment. It's very elegant too. And Paul had the lid off at Hamvention, and the component count is really quite low for the functionality. So he did an extremely nice job of engineering that thing. There's no question about it.
So what is Paul's background?
Electronics. I forget the name of the company, but he was one of the engineers that started up a company that sold out during the dot-com peak to Cisco. Perhaps enough said.
Okay, very nice. uh, very nice. Right. Were there other sets, Seguin? Were there other sets of 3 people plus WWV that had similar results? Do you have another set of people?
I don't want to sort of halt this because the danger is that I can keep going.
Well, go a little bit more then.
We'll go a little bit more. Okay. Well, okay, right. Let me bring up a screen just for a moment so that I'm not too embarrassed when I when I open it up. And so I guess yes. So Whispersond. So we have real-time data from the Whispersond that goes into Rob Robinet's Whisper Daemon database, and we can query the database in real time graphically using this Grafana graphing package that directly accesses the database, and where we use pull downs to select various parameters. So this is the Whispersond at Paul's location, and he has 2 sites. So I've now swapped to Paul's site at Occidental, California, just to the west of Santa Rosa. And this is the path. The receiver is Michael AC0G, just outside Columbia, Missouri. And this is on 20 meters. And this is 17th and 18th of May. And this period here is during that LSTID event. So you can see the Doppler. It's not every 2 minutes. He's missing sometimes, but you can sort of squint and think that you can see a Doppler trace there.
Sure.
Yeah.
Yeah, I could squint.
You can squint and see that. And then we also get the width of the spectral width of the transmission, and we get signal level down here. And so then it's easily clickable, so you can go to another receiver from the list. Let's go to Glen Elmore N6GN's remote. So this is at Glen's remote is at just outside Fort Collins, Colorado. And look at that nice trace. So this is from the Whispersond transmitter to Glen's remote just outside Fort Collins. So what we can do with this now is to look at reciprocal paths, because Glen is within line of sight of WWV. So here we have a receiver within line of sight of WWV that's receiving the Whispersond at Occidental, California. And that is 20 meters. We can go and have a look at 30 meters. And yeah, so, okay, so there was no reception on 30 meters during that time. But look, during the night on 30, something else was going on here. So, and other Whispersonds. So there is a Whispersond in Costa Rica, John, TI4 JWC, and this again is reception on 30 meters at Glen, Fort Collins. You know, you can go to 15 meters. No, hardly anything. Sorry, I haven't prepared any of this, so it's, you know, you're seeing what I'm seeing. 30 meters, there we are. So what this allows you to do is to very rapidly, with no programming skills, is to explore that data entirely graphically, pull downs. I mean, what you do need is the knowledge of, you know, where these stations are, and so on. But it's dead easy to explore and to have a quick look.
So, how do we find this database?
There are many links from the Whisper Daemon database. Now, so I'm going to put this information in chat. So I'll copy the URL. Where's my chat gone? Oh, that's odd. It was there because I. There it is. Right. So that's a URL. User ID is WD read. No, everything has a spell checker and wants to correct my spelling. WD read. Password is JTWSPR in capitals 2008. WD read JTWSPR 2008. And that takes you to a home screen. That I showed, that takes you to a home screen. Which has got lots of dashboards. Or the only one I just showed there was WhisperSound, the one down here. And there are, you know, you can explore to your heart's content. The ones that I've starred are the most popular ones. But I put the URL in chat and the user ID and the password that you need.
Yes, thank you very much. So with your experience, what would be the best way to explore this very rich site for what happened during the eclipse? What would be a good thing to do? What do you think?
I think it depends on your interest. I did write some short one-page notes on various aspects of the data that gathered by the Whisper Sons and Whisper Daemon during the eclipse. That they are on the Whisper Daemon website. And I mean, those would give you sort of an idea of the sorts of analysis that one could do. So one can do Doppler. One can do, you know, spot counts, heat maps of, you know, spot count versus distance from a particular grid square. You really need to have a look and see what's already there.
Would you be willing to, well, to send these one-page documents to me or to Gary or somebody?
I can again put the link in chat.
That would be good. That would be nice.
So this is to the sort of technical page of the Whisper Daemon group of people, and so that, you know, there's information there on the Whisper Sond, for instance. There's the sort of 8 one-pagers that I wrote about the eclipse, the October eclipse, and various other items are already up there.
I don't know. I see a lot of wheels turning behind Mary Lou's eyes, so I know she's getting pretty excited about it. I think that was time well spent, Glenn. Thank you very much, because that's the whole purpose of this call is to explain and understand and share scientific knowledge, essentially. So you were right on target. So we're glad you showed up today.
Thank you. Yeah.
Yeah, this sounds really exciting and interesting. I love to look at graphs. I love to watch things go up and down, and that's really cool. Thank you.
I would like to take a second to, Kent, I don't know, I can't recall if you've been on our calls before or not, but we had a long time looking for a Grape 2 host in Alaska. And Kent volunteered for that and is also considering being one of the sites for the VLF HF magnetometer project should that stuff come about. So is there anything you want to say, Kent? It's good to have you here.
I'm glad to be here. Thanks, Gary. It's excited to try to help out with this. It's a good site down there in the Kiski. It's very radio quiet. We've got a great noise floor there, so it's helpful. If any of you are contesters, I'm not very far away. The site's not very far away from KL7RA, the contest station up here in Alaska, and I contest there regularly. So that's kind of handy. But I don't have anything really going on at my house other than some microwave mesh stuff. And so we try to keep it quiet there. And I'm really looking at this site. I've got about 3.5 acres and would like to put some other experimental devices on this location. I think it would prove useful. So anyway, it's out there and looking for opportunities.
So you have a magnetometer there? Are you going to get one?
Would like to, do not have one yet. Want to put one in though. Yes, yes.
Interestingly, at the Hamvention, there was a lot of interest in the magnetometers, more than I expected, just because we haven't, how should I say, advertised it a lot in HamSCI compared to some of the other things we do. And in the back of my head, I know we need to do more of a DIY, how to build it, how to install it guide for the magnetometers. The documentation there is very good, but there's a couple little gaps in it. In fact, Nathaniel, I think Majid built the one sample tube and stuff that you guys have there at Scranton. We get into this maybe later this summer. It might be nice if he could write up some documentation on how to build that tube, essentially components, lengths, all that sort of stuff. And I think that would be a big help.
Definitely.
To the magnetometer network.
I do have a question on that, on the
Sure.
magnetometer, Nathan, Nathaniel. I've looked at magnetometer installation up here before, and as I understand it, for magnetometer installation for those sensors, they need to be below the frost line. Is that correct?
Well, the goal is to get it temperature stabilized.
Yes, right.
So
okay, so that's a little, so that of course is a little challenge. We run deep here on the frost line, so we got to go pretty deep. So that's what I'm trying to figure out, what our actual frost line is, so we can find stability below that frost line, if you will.
What do you mean by deep?
Well, for instance, we put our water lines 10 feet, at least 10 feet deep here.
Yeah, and of course you got permafrost, so it goes very deep.
Yeah, some places I don't have any permafrost on my property, but that I'm aware of anyway. But yeah,
lucky you.
Yeah, so yeah, we've got to go pretty deep. So that's trying to figure that out. I don't know the best way for me to determine exactly how deep my frost line runs on my particular property. So anyway, stuff to figure out.
All right, good. Yeah, thanks for filling us in on some of the details up there, because it is nice to look at our map. I know Nathaniel included, you saw it earlier, the map of stations or potential hosts and stuff, and it was good to see the state of Alaska represented. Now, if we get Hawaii, that's one of our challenges too, and obviously the less populated states in the northern tier. But we'll get there, I'm sure.
I think it would behoove us to see if we can just temperature compensate the readings. Because I have the same problem in New England.
in New Hampshire, our frost line supposedly can go down to 6 feet, but then our bedrock can be closer than that.
Hmm.
So I can't resist showing this one. Magnetometry. So this is an RM3100, the same as in the HamSCI magnetometer. This is at my good friend HamSCI OH8GKP, just shy of 66 degrees north in the northern part of Finland. And so that's his RM3100 in yellow. And wonderful thing about Finland, there are many national magnetometer stations that make their real-time data available. This one is code OUJ. Now, you know, that's a pretty good match, isn't it, for the anomalies?
GLN.
I'm sorry? I missed that.
I think there may have been another conversation going on.
Marion has a open mic.
Yeah. Sorry about that.
RAN is another one of the magnetometer sites, and you know, you can see some differences there between them that one could look in terms of separation.
So put that back again, please. And explain to us what the yellow and orange lines are, and then what the blue and purple lines are.
So the yellow, the top panel is the horizontal component anomaly in nanotesla. So it's the deviation away from the average over this entire interval. So there we have 0. So we're looking at anomalies because there certainly is slow temperature changes, which makes comparing absolute values difficult. So this looks, these are anomalies from the average over the duration of the image.
Are you comparing a flux gate to the 3100?
That's the 3100 is in yellow, and the IAGA site from the Finland National Magnetometer, RAN, is in green for the horizontal component, and then these two, the magenta is the RM3100, and the cyan is the National Magnetometer.
That's
How
the
far
vertical
apart are they?
component.
Sorry?
How far apart are they?
Oh,
Horizontal. These
so
two
I
places,
need to go and have a look at the map.
but hundreds of kilometers or something.
Hundreds of kilometers. Which one is his closest?
I've seen other comparisons of Fluxgate to the 3100, and it's really primarily a matter of noise. Than they're actually quite, they agree quite well.
Yeah, so this is the closer magnetometer, OUJ, and you can see that there was less variation around this period, for example, than on the previous one. And then you can zoom in.
So the top one is horizontal and the bottom one is vertical?
Correct.
Okay.
Yeah. You know, there are some differences, of course, but you know, the tracking is pretty good.
But essentially, you've used mathematics, or they've used mathematics to take the temperature variation out of the readings. Is that correct?
Heike he is in an insulated buried box.
Ah, okay.
And there's no correction. There's no numerical correction for temperature. But what we do is to just plot the anomaly from the average for, you know, whatever I set that to. That's about 1 day.
And that would be useful because as you go along through the seasons, it gets colder, 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 and yet you can have the same thing at the same level once you subtract off the daily average, right?
Yeah, yeah.
interesting. Very cool.
I don't know if it's appropriate to interject here, but we did discuss with Pierre Fogel placing a magnetometer up at Ellesmere Island this summer in northernmost Canada. That it seems like that would be a good candidate. We actually gave him a whisper sonde, which he's going to deploy up there. But it would seem like it would be a really unique site for the whisper for the HamSCI grape network to have a site, a fully capable site up there at Ellesmere Island. I mean, that's, I don't know, several hundred kilometers from the magnetic North Pole. So I don't know, maybe I don't know what you'd measure up there. They, perhaps there is already a commercial one up there. I don't know, or it would surprise me if there weren't one.
Yes.
Given that,
Does anybody live on Ellesmere Island? What is it
yes,
like?
Ellesmere is it's a polar area research station for the Canada, maintained by the Canadian government. There are researchers that live there, a few that are there through the year, but of course, most of the research work is done in the summer. And Pierre will be up there in, he thinks, late July. So we were going to upgrade his receive site and to do grape reception, Whisper Demon, maybe RBN. I mean, Super Darn. I mean, they've got good internet connectivity at this point, and we could be recording all of those simultaneously off of one RX 888. The issues are not are more our problems with Ellesmere have been that the antennas keep getting destroyed, receive antennas. So we're hoping that this year he can put up something that's more durable and survives the winter.
So is it snow and ice that gets them, or some polar bear, or what?
It's the animals. The animals attack the antennas and the feed lines. You know, they I guess they eat them. Well, the insulation or something motivates the animals to attack them. We don't know what happened this winter, since Pierre hasn't been up there. But since
Because
we
first
lost,
they ate the camera, right?
I say, yeah. So
Well,
The
we used to
Ring
have,
doorbell camera they ate first, then they
when we had
distributed stuff.
when we had equipment in at Sonderstrom in Greenland, the problem was Arctic foxes would chew through our cables.
yeah,
They really liked the human scent. You had to be very careful about human scent on cables. But then they, you know, there are other places where the caribou will and moose will use the antenna mast to rub against and all, or they'll just walk through it.
well, anybody who has experience up there, I think Pierre has also a Whisper Beacon network, which is a group that has deployed some Zactec up there, and it has been feeding a end-fed long wave. It's just a 80-meter long wave, and it apparently has survived. I mean, it's still running. So I've suggested to Pierre that he just ought to, just try an end-fed long wave. Let's not try to optimize the antenna system. Let's try to for anything but durability. The rest of it is, when it was running, I think we got very interesting data from it, but it didn't run through the winter. So it's anyway. I'm have to get assemble the equipment for him because it has to travel with him when he goes up personally. And unless someone, we could get a more formal commitment that was approved by the government, and we could have some person dedicated to go up there. for Pierre, this is a hobby side project, and of course, his time is so booked when he's up there on his professional responsibilities that he sometimes doesn't have time to finish working on the ham associated and volunteer activities like this. So it would be great if we could get a more formal commitment through the government. I mean, I think it costs like to send someone there. I think it costs like $100,000 or something. It's a extremely expensive trip. So I don't think we'd want to take it out of the track 2 Daisy budget, but uh, but I think if anything we could do, Pierre is eager to help us, and we've had years of working with him, so he wants to help us. So if anyone has, I can't do much in terms of the magnetometer or ELF reception. What I can do is ensure that there's a whisper, work with him on a whisper sound transmitter and a and the whisper demon grape receive system. And we're doing Super Darn and other recordings and grape recordings off of that, so we can record virtually anything simultaneously. Now you can't transfer gigabytes back because it's a Skylink connection, so you kind of have to do the analysis work if you want to do culling and analysis of the programs. And this is true, I think, for a lot of sites, is that if you're recording these high bandwidth signals, you really need to consider how could you process them and analyze them locally rather than trying to transfer the recordings. I mean, it's 40 gigabytes a day of data from the 4 Super Darn channels. So it's not trivial. Anyway, that's my end of my.
No, it's good, Rob. Thanks. I mean, it's we a lot of us sit here like I do here in the suburbs and look outside at grocery stores and all the other conveniences of modern life, and it's good to remember that there's people doing science in pretty remote areas, having a good time at it, from what I've heard sometimes, but it's still not easy to get there. And a lot of risk involved too, actually. So.
Well, I'm working with him to upgrade his what I can. But if somebody wants to help me with him with a magnetometer and ELF again, let's get together soon, because it's only 2 months away and I'm gone for 3 weeks of it. So and getting stuff into Canada can be a challenge. So.
Do they ever, at these remote sites, if they have problems with animals, ever put electrified fence around the whole thing to keep the animals out?
I wouldn't know.
Because one of my friends has a farm near here in New Jersey, and they have beehives, and they've discovered that the bears know where the beehives are and that there's honey in those things. So they have an 8-foot electrified fence around the beehives.
Well, I know that
electrified fences are not good for radio.
Yes, yes.
Oh, there's point. That's a good point.
Yeah, Glenn Elmore has a remote site that's on top of the mountains above, looking down at WWV, and he has used a loop on the ground, like right on the ground. In fact, a little under the ground, I think. And I think that's been it works well and survives the winters up there when there's no, anything short of snowmobile is inaccessible. And he never goes up there for 6-9 months. So that loop on the ground has been one approach to addressing these sites. But I know Ward mentioned at HamSCI that there's a reference antenna under consideration, right? Is that you developed for calibrated receive site measurements. What does that look like? And
antenna is described in the new antenna book. Receiving antennas chapter was designed by Witham Reeves, who's not a ham, but pays pretty close attention to HamSCI. I think he works at HAARP. It looks like a little flying saucer, basically. It's like a cross pair of very wide strip dipoles that are not very high off the ground. And so the whole thing's about 6 feet wide and 3 feet tall maximum. I asked with them, the antenna is designed for 6 to 40 megahertz, if I recall correctly. And I asked him if it could be scaled to do, say, 2 megahertz to 30. He said, no problem. They've tested it over that range. So one of these days, which may mean never, I'll get around to trying to build one of these things and see how it works. But it would be nice to have a few standard designs that we could ship out with the nodes that were well characterized and had an approximate calibration. Possibly, maybe we could even come up with a calibration mechanism. But at any rate, there's quite a random selection of antennas out there now. The active antennas are okay, but performance is variable. And perhaps this is another tool in our kit. Thank you. Back to Nat.
It's pretty exciting. The fact that the design's published in the antenna book too means that a person with probably average skills could probably build one of those things and be successful at it too. So that's even better news.
Well, I thought it would be good to have some radio astronomy antennas, since that's certainly a receive antenna. And there is some overlap between the Society of Amateur Radio Astronomers, and I don't know where the comma is. Is it amateur radio astronomers or is it amateur radio astronomers? I'm
That's the one.
not sure. About 50-50 as far as I can tell. So that may be another open door to the HamSCI group, is through the radio astronomy people.
I've worked with Rich Russell for some time. Yeah, there's possibilities.
Yeah, there's a big paper that he collected input from and edited, and it was at least supposed to be sent out with the antenna book. I'm not sure it actually was. It may be on the web page. It's about a 50-page PDF with a lot more than I could squeeze into the antenna book.
Nice. All right, I see it's getting on. It's a little bit after 5 o'clock. I think we're good. We've got a couple of people traveling. It's also summer. It's vacation season. I think a lot of people will be on the road for one reason or another, myself included, next couple of weeks. So I'll see what I can do about getting the sporadic e-talk next week. We'll also make sure that's recorded as well, because if we can have the talk and we don't record it, we'll lose a lot of the benefit of it too. So other than that, is anything else anybody wanted? Otherwise, we'll wrap it up. And
I have one note.
Sure, Ward.
Okay, I'm in conversation with Ashraf Chabani, 3 Victor 9 Alpha, also known as Kilo Fox 5 Echo Yankee Yankee. The total eclipse in 2027 will go right over his house in Sfax, Tunisia. And he is very interested in participating in yet another solar eclipse event. And there are a bunch of the Tunisian hams that will also be interested. And there are some Tunisian students that he's mentoring through all this who will be showing up on HamSCI. So we have a kind of a long-term project there. There will be a lot of opportunity for stations to operate not only in the path, not so many in the path, but across the path in North Africa. So that's something to be thinking about over the next couple of years.
You said that was what, 2027?
2027. I think it's
Okay.
August, might be April. I don't remember. It's an A month.
August 2nd, 2027, and a path just goes right across North Africa and down the Red Sea. It's
You want to see a total eclipse at the Great Pyramids?
Whoa,
It's going right over
Ooh.
Luxor.
whoa.
Oh, let's
There
do
should
it.
be some
Whoa.
serious
Ooh.
tinfoil hattery going on.
The Airbnb prices are going up as we speak, I can imagine.
Everybody in Carbondale is headed for Egypt. So
Yeah. But there's so few receive sites. There's almost nobody who receives in Whisper in Africa. And not even many, I think, hams operating FT8 and 4 in Africa. It seems like, that might require some mobile installations to be able to make good measurements across the path totality.
we have 3 years.
All right. Okay, if that's it, then we'll call it a wrap for this week. Next week, like I say, it's kind of an optional session. We'll see what we can do to get about getting a sporadic discussion going. No promises. If not, we'll meet back again, I think, in 2 weeks for pretty darn sure. So, all right, everyone. Thank you for the participation. We covered a whole gamut of topics, but they're all very interesting. So, hope everybody took something or many things away from it. So, 73. Have a good couple of weeks and see everyone again soon.
Okay.
Now.
So long.
everybody.